Imagine if you were able to watch all the hundreds of cable channels on TV at the same time. It would be impossible to watch them all at once, and extremely difficult to watch just 5. Although you may think you can watch 3, in reality your brain is only capable of alternating between 2 distinct channels. This is the same dilemma that multi-camera systems deal with every day. Because it's not cost-effective to hire enough people to watch all the video feeds in real time, computer programs are applied to these scenarios. In order to monitor video feeds simultaneously, computer programs from the research area known as computer vision have been developed to help in the detection of targeted events. These programs run complex mathematical formulas known as algorithms in order to find when and where a targeted event occurs. This process is known as video analytics.
Video analytics is really about trying to understand images and video in the same way that people do. The goals are to understand, learn, and draw inferences from the video that you're given.
Video analytics are used in many different industries such as security, retail, transportation, and sports, just to name a few. Cameras, teamed up with analytics software, can process video feeds continuously in order to derive important information for people to use, accurately, and in real time. For example, this process has been widely used in sports, like in the recent Olympic Games. Cameras and programs analyze athletes' motions, while the viewers at home get immediate quantitative information like speeds and timings. The use of video cameras is widespread, especially in the security industry. There are so many cameras now that there are not enough hired officers to watch them all at once. Before we can explore how video analytics plays a part in security, we must understand how computer vision works at a more basic level.
Computers see images as data. A video feed is 30 frames per second typically, and each frame has hundreds of thousands of pixels with red, green, and blue values. That's a lot of data. So a way that computers can understand that data is by first grouping pixels that are similar into blobs that represent an object or a part of an object as something is moving in front of the camera.
Blob detection helps a program begin to break down the complexity of a scene into basic components so that it can more effectively track. Tracking objects through space is a key component in the implementation of video analytics in the security industry. A scenario as simple as a program having to track an object through a scene can be deceivingly difficult. Because a video is a two-dimensional representation of three-dimensional space, it can be very difficult to teach a program how to deal with overlapping or crisscrossing objects.
The first step to detecting objects in video is usually to build what's called a background model. This is like an empty image of the scene that doesn't contain any moving objects or people. Then I compare the video that I have against the background model and say that regions of the image that look a lot different than the background are likely to be moving objects. But this is a lot harder than it sounds because, for example, I may be wearing a white shirt that's similar to the white color of the wall behind me, so I'm difficult to find. Or I may be moving in a big group of people, and so it's difficult to pick me out individually. Or even more complicated is changing illumination in the world. So for example, sunlight may be coming through a window, casting shadows on the background, so the background model is actually changing over time. These are all very difficult scenarios.
This example leads us to the idea of teaching programs how and what to see.
Computers learn by examples. So it learns by looking at what activities there are, annotated activities, what is good activity, what is a bad activity, and sometimes unseen activities. And by looking at lots of these examples, it can then help the computer to figure out in real time when something happens to determine what it is.
There are already applications in security that are understood by programs today, such as counterflow analysis tasks. This is a scenario where a program watches for any object that moves in the opposite direction of a predetermined direction. With advancements in research, tasks and events that the programs can watch for will become increasingly complex, such as flagging unusual behaviors or following identified targets through a large network of non-overlapping cameras. Like in any emerging technology, as more progress is made, more challenges are revealed.
In the near future, I think you can expect to see video analytics algorithms that will do things like automatically track all the moving objects in a crowded environment, associate passengers with bags at places like airport security screening checkpoints, or even take a person's cell phone camera and tell where in the world a picture from that camera was taken. However, video analytics are not going to solve all of our problems automatically. Oftentimes we really do need an expert human in the loop to solve the problem. But video analytics can dramatically cut down on the amount of video that person has to look at manually, and that's where we're going in the future.
The presence of our hardware and software in security settings is expected to produce a wealth of new data and research problems to be addressed for years to come.